I first want to introduce the moderator of the panel, Rear Admiral Joe Carnevale. Joe, I'm hoping, is a Red Sox fan.
Yeah.
Oh, well, okay.
I grew up in Pizza Field, so we
Yeah.
were Yankees too.
All right. Joe is a UMass grad with a BS in chemical engineering, MIT grad. He's been around. His job right now is to speak before Congress for the Shipbuilders Council of America, and he's been in this business for a while. Anybody who retires as an admiral has earned their stripes, as they say. I think probably one of Joe's coolest jobs that I ever saw was he was in charge of the repair of the USS Cole, which I saw that ship come back to life, and it was impressive. But with further ado, I'll let Joe take over.
Thank you.
All right, good luck.
Thanks. All right, I a long time ago transitioned from merely old to really old. All right, well, let me give you a little background on this format that you're seeing before you for this panel today. At the Fleet Maintenance and Modernization Symposium in the Hampton Roads area last fall, Rear Admiral Rick Berkey came up to me and we were talking about the next JINI, Joint Industry Navy Improvement Initiatives meeting. And he said, you know, Joe, the problem with those meetings is the Navy does all the talking and we never hear from industry. So a couple months later, I'm sitting at one of the meetings that was held between ASNE and Marine Machinery Association to coordinate the events of this week. And Jack Janitatos is sitting there saying, you know, those Navy folks, they're always great at coming and talking to us and telling us their views, but they never stick around to listen to us. So I'm going, well, what the heck? You know, we ought to be able to sort this out. So this is a point-counterpoint panel to try to go exactly at that problem. You know, where there's not a real dialogue and where both sides get to talk and both sides get to listen. And I sincerely appreciate the participation of all the panel members, except for Mark Whitney, of course, who got called away to join Admiral Kevin McCoy over at the Pentagon. It was unavoidable, last minute. And so I will be the acting Admiral Whitney, but to show you where my real loyalties lie, I left my coffee cup over here. So if you'll bear with us on that. The rules of engagement are I'm going to do a coin toss to see who asked the first question. And it's one of these coveted ASNE's president's coin, with the ASNE symbol being the heads. And of course, the government is the heads, and of course, industry is the tails. One side will ask a question, the other side will answer it. And we'll go back and forth alternating as to who asked the questions. It's up to the panelists themselves to determine what order they ask the questions in. And I have never called these opposing panels. These are opposite panels. Because controversy is not the objective here. Communication is the objective here, is to have both sides get the benefit of the other side's thought. So with that, what I'm going to do is I'm going to introduce this illustrious panel, starting on my far left and working my way around to my far right. And just to give you an idea of the broad experience that we have here today in our panels. Starting at my far left is David Rathburn, who's Chief Executive Officer and co-founder of US Joiner, the leading outfitter of habitability in America. Prior to joining US Joiner, Mr. Rathburn served in numerous capacities with Hopeman Brothers Marine Division, where he was ultimately named president in 1991. He's also served as AWH Corporate Vice President. Mr. Rathburn is the chairman of Shipbuilders Council of America's Industry Partners Committee and serves on the board of directors of Shipbuilders Council of America. To his right is Roy Arnold, who is CEO and president of IMECO. Roy was educated at University of New Mexico, where he got a BS in mechanical engineering. But Roy started his career as an engineer at the Naval Ship Weapons Systems Engineering Station at Port Hueneme, and moved into private industry working for a marine deck machinery manufacturer, and then almost 20 years ago formed his own company. And what was very interesting interesting about his very early career is he worked on the reliability of deck machinery, and some of that equipment 35 years later is still being installed, and many of the equipment is still operating over those 35 years. In 1992, did good. In 1992, he co-founded IMECO. The company drew heavily on the technologies and shipbuilding processes that evolved in Europe as their markets diminished. The company's been a driving force to focus the supplier base across U.S. shipbuilding. To his right is Michael Ripich, and he is the president of AT&F in Cleveland, Ohio. AT&F is a global producer of components for large-scale construction and mining equipment, fabrication for shipbuilding and defense, power plant components, specialty stainless steel and alloy process equipment to serve the chemical industry and alternative fuel producers. Michael began at AT&F in 1989 as Director of Training and Development, subsequently held lead positions in human resources, operations, and business development. Since 2008, he served as President of AT&F. He's an alumnus of Boston College, Case Western University, Reserve University, and Harvard Business School. To his right is Tony Sabbatino, who's president of Bogue Systems. Bogue Systems has been in business since 1892. They're designers of power conversion equipment, uninterrupted power supplies, and battery chargers. They specialize in AC and DC motors and degaussing systems. Tony's been president and CEO since 1976. He founded Inventron, an ultrasonic means of measuring, held positions of president of Acoustica Association, a supplier of propellant managing systems for space boosters, and he was an engineer for Douglas Aircraft, designer of the DC-8 original cabin electrical system. To my right is Admiral Rábago. He's currently serving as Coast Guard's Assistant Commandant for Engineering and Logistics, CG4, as the Coast Guard's Chief Engineer. In his previous assignments, he's been the Assistant Commandant for Acquisition and Chief Acquisition Officer, the CG9. He's held many important positions in the Coast Guard, including Program Executive Officer, Director of Personnel Management, Deputy Commander of Maintenance and Logistics, Command Atlantic, and Commanding Officer of Coast Guard Yard in Baltimore, Chief of 5th District Law Enforcement Branch, Commanding Officer of Coast Guard Cutter Tampa, and was XO on Boutwell. He's a '78 graduate of the Coast Guard Academy, and in 1995 he was named Coast Guard's Engineer of the Year. To his right is Rear Admiral Dave Lewis, born at Misawa Air Force Base, Japan, and was commissioned in '79 through the Navy ROTC program at University of Nebraska. At sea, Dave served aboard the Spruance, the Biddle, the Ticonderoga. He was the Aegis Shipbuilding Program Manager, where he helped deliver 7 DDG-51 class ships and procured another 10. And now he continues his long, illustrious history of buying and delivering Aegis destroyers. That career was interrupted by duty assignments as the Executive Assistant to ASNRDA, Chief of Staff for Maintenance and Engineering at Surface Force Pacific, and he was also the Vice Commander of Naval Sea Systems Command. And to his right is Rear Admiral Tom Eccles, who is the Chief Engineer for the Navy. He was born on Johnson Air Force Base in Japan, raised in Wallingford, Connecticut. He has 4 degrees from MIT. He's served at sea on 2 submarines, the Richard B. Russell and Gurnard. He's worked in the deep submergence programs, the Virginia-class program. He was the Seawolf program manager through the delivery of the Jimmy Carter, where his team got the meritorious unit commendation. He's been the NAVSEA's chief engineer since September of 2008. You got to be careful what you wish for. He led the technical team supporting the Republic of Korea investigating the loss of the warship Chonin, and was appointed to the Naval Academy of Engineering Committee examining the Deepwater Horizon explosion. So he is not only CO5, he's NAVSEA. So with that, I will toss the coveted coin without dropping it, and it is heads. So this side will ask the first question.
Okay. I'm going early because this voice may not make it the next 2 hours or whatever this is going to be. My question is going to start with a little bit of a scene setter. If you go back about 25 years or so, a case study at the Harvard Business School looked at components being produced by the company Black & Decker. They were in a restructuring, having a tough time, and they pulled a miraculous kind of a save in a business model that went from a really wide variety of parts, not unlike the way we have lots of different parts in our ship systems and complex componentry. They looked at what they had for a customer base, which was wide, from consumers in homes like us to professionals building big stuff, and they said, what do we need to do to reduce the variability and the variation in our product line while still having diverse product offerings for different needs? And they found a solution in essentially a single motor design in 3 sizes and made their whole product line built around that kind of simplification. With that, they found lots of economies. They reduced price to consumers and regained market share, did a great job of a fundamental kind of restructuring in a product line. So that made an impression on me, and I've been thinking for years about how to make that apply in the shipbuilding business, where if I say, well, I want a common air conditioning plant for an aircraft carrier, an LCS-sized ship, a destroyer in between maybe, and let's also have one that's quieter than quiet for a submarine. Right, those are not the same machines. On the other hand, why are compressors necessarily so different everywhere in the product lines as they are today? There are economy opportunities, and so my question as I drafted it was something like, what steps can be taken by equipment suppliers, and I mean complex components generally, to achieve more common solutions for Navy needs across multiple ship classes? Thanks.
I can tell you what we're doing. Getting very little help, though, from the parties that probably could steer us in the right direction. Recently, we developed a system with software and with hardware that is applicable to other power systems. In other words, we can modularize it. Our degaussing system is now fully modularized. The degaussing system that we have would not fail. A single failure wouldn't put it out of business. If you lose a coil, you're not out of business. And it does several other things which are important to a ship. We're big producers in Europe, on European ships. But what we're trying to do with all of our power systems is using modules, IGBTs, that if I needed to replace an IGBT to get a little more power out, that's all I have to do. But everything else is the same. You know, what I've been trying to do is get some feedback from Philadelphia, and I've received goose eggs, sorry to say, asking them questions as to what should I be looking at in the way of power. There's a lot of UPSs on ships, et cetera, et cetera. On the 1000 class, we have PCUs 15 all the way up to 150. They're all the same. The hardware is the same, excepting for modules. And that's the route we're taking. But it's hard to get information.
Yeah, so if I understand that right, largely to make the modularity work, you've got to have an architecture that's open to all these different size modules. That
Correct.
means that the backplane's got to be able to handle power at the level that you imagine you might upgrade to, right?
Correct.
So an interesting problem for everyone, I think, is if we were to let the ship program manager know, and he's not listening, so it's okay, but if he were, and he found out that we had excess cost, as some people would look at it, in the components, so that we could someday go to a requirement that's not yet out there, right, then there'd be a call maybe for going down, actually reducing that margin. And this is an interesting problem, and I'm not really accusing Dave. He's actually a champion of having the right openness and the right vision about the future and building the margins for it, but it comes at a price. At least some people would argue that. I would argue with you that is on your side, that getting that right up front is the way to save money in the life of the ship. And so you ask a great question, and we, I think, owe you some answers on how do we structure the requirement side so that we're open to envisioning that future.
That's kind of my question. What's the pushback from the government? what you say makes a lot of sense. So why are we not agreeing with you?
I don't know that they're not agreeing. I think they're busy and they don't respond.
Just ignoring you?
Yeah. And I happen to know the gentleman real well.
That- I think you could maybe fix that.
We might be able to work on that. Yeah.
Any other responses from the industry side?
Yes, I think your example on Black & Decker is a good one, and it would go along a little bit with this last conversation. They treated their equipment kind of as a system, and they reduced the number of parts. So I think this would require collaboration between the ship design and the suppliers, because it's the ship design that needs to be, you need to look at that functionality and find the simplest way to get that functionality. So while it's a supplier issue, it's really a system design issue, I think.
Interesting. IBM had a thing called the golden screwdriver. When they first came out with the IBM 360, their customers thought there were 4 or 5 different models of the IBM 360. The reality was they were all identical. And what they did is when you ordered the base model, they thought you'd upgrade, so they just bypassed some of the functionality. And after you'd used it for 6 months and said, "This is awesome, I want to upgrade," they'd go, "Okay, well, it's going to cost you." But the repairman came in with a screwdriver, and he unbypassed parts of the machine and said, "Okay, weekend install over with. You got your great new machine now." And it was a very successful business model, but they only made one computer.
I think I'll beat you on that one. We're on a ship in San Diego, and it's on a converter. And he needed 90 kVA. We had 45. So I was on that ship. And so we took and replaced the resistor and put a little bit of a relay in there, and he had 90 kVA. So
Same idea.
Yeah.
I think to Mr. Arnold's point, one of the important observations is that shipbuilders and component suppliers need to be really tightly coupled on this. And of course, since we're kind of all over the same problem, the Navy's got to be in it too. But then when you look across classes, very often we're crossing shipbuilders, right? Because especially if you scale this from nuclear to non-nuclear powered ships, and you go from the undersea all the way to carriers and in between with ships of varying types and surface ships, if we found a typical component that is represented in all and at the right scale could be replicated all the way through, and maybe the compressor in the air conditioning plant is just an example, then since we're crossing shipbuilders, we can't optimize just around whatever's best for one or another, because it's only going to touch a couple of ship classes, perhaps. I think that to do it right, there's got to be an industry construct that parallels with a Navy construct and says, how do we get partnership in the big vendors of complex components and the shipbuilders they supply to? Often a single type of component is today not even competed, but if it were in a competitive environment, then those competitors would be working with 4, 5, 6 shipbuilders and then one Navy customer. But in the one Navy customer, there's Dave Johnson, there's Tom Moore, and Jim Murdoch, and so really it's like 4 different C-frame buyers in the Navy. On the Navy side, the PEOs, like Dave, have just begun trying to enter into those kinds of discussions with shipbuilders by sitting down across classes. And we need to get the word out that we're beginning to do that, and we're trying to do it in some targeted industries and targeted components so we can start bridging those gaps. But I appreciate your comment.
How do you do that with your, I mean, you deal in a commercial world with a broad range of customers. How do you do that? Or if you have one customer that has a broad range of products, do you have that environment?
Well, to an extent, the customer does it. And let's take commercial shipyards as an example, and commercial ship owners usually have a maker's list. So they automatically narrow it down to the group of people they work with. which is harder for you with all the procurement rules and things, but that's how it's done commercially.
I think we should move on to the next question. And what is industry's first question?
Thank you, gentlemen, for being here this morning. As we've been here this week, there's been a lot of discussion about approaches in shipbuilding, and it's understandable that Navy and industry need to be focused on cost reduction, particularly in the current environment. The should-cost approach to procurement is perceived, at least certainly by many on the industry side, as being adversarial. On the other hand, subcontractors and suppliers work collaboratively with shipyards to identify savings opportunities, such as those we've just discussed. In your opinion, is should cost a more effective tool than collaboration to reduce the Navy's cost of procurement?
Okay, so I guess I would start by, in a way, countering, but not to reinforce the idea that it's adversarial, right? But I would say that the two go hand in hand, that an understanding of what should cost means to us and I hope could be a common view is one that comes with collaboration. And so I would not look at should cost as something like this is all I've got and therefore it should cost this, but more like I can't, some people know what dead reckoning is, but where we're working our way down a range and we're trying to navigate and we're doing it based on an expectation of where we're going to be based on where we've been. If all we do in an environment of some cost growth is project future cost growth, then we're reinforcing a behavior that needs to be countered. And so a should cost notion compared with a prediction that's based on priors is challenging the assumption that just because things cost a certain amount so far doesn't necessarily mean we're going to continue on the same trajectory. But that in and of itself isn't adversarial. Actually, it can be a real partnership, a collaboration of what is it that underlies the cost. How are people arriving at an end state where it did cost that much? And if the answer is, boy, there's some baked-in inefficiencies that came from the way we spec'd the job, the way we oversaw the job, if there were opportunities missed in industry because we didn't get the right collaboration across product lines, then all those things can go into changing the course of continuing increasing shipbuilding costs to drive them in the downward direction. So I'd see the proposition as how do we show that we can do something about changing the direction and do it in a collaborative way. And at this point, I kind of hear that song from the Coca-Cola commercials in the 70s about teaching the world to sing, so I need to turn over to Dave.
I think for me, should cost is the first step is the government. It's literally what the word says. What should this cost? And frankly, we've fallen into some bad behaviors in several areas where, as Tom described, what it should cost this year was what it cost last year plus 5%. And that had been going on for a while. And so there had become some clear and obvious divergence between what we were paying and what it should cost. An example is a device we were paying $300 for could be procured on a commercial market for $110, excuse me. And our should cost analysis was to tear the two devices apart on a table. Every bolt, every screw, every nut, every piece of casing. And what we found was one $20 part that was different between the part you could buy on Amazon and the part we were buying for a ship. And that was an internal government analysis. And then we went to industry and said, we think this should cost $130. You're charging us $300. Now let's have a discussion. And in that sense, it was the government coming to understand what that device should cost, and then that became a basis for a discussion about what should we pay for it. And I'd acknowledge that maybe we should pay a little more for one reason or another, maybe not, I don't know. So for me, as a PEO and on the program management side, it's literally what the words say, is what should this cost? Ignore what we're paying. What should it cost? Because there's been some behaviors over the years which have caused a cost to arise, and in several areas, I'll give you one example, there's many more, we felt that the actual costs versus the should costs had diverged.
Yeah, I would make just in parallel conversation. One of the things that we've done in the Coast Guard is strengthen our estimating processes. We've partnered with Navy as well as talking to commercial vendors to make sure that we understand how the estimating process works, so that we literally do the same sort of thing of being able to tear it down. You can't even have a discussion in terms of negotiation for a cost unless both parties are well educated into what all the things go into that particular cost. And so what we've done is we've strengthened within the Coast Guard our ability to understand where those costs are, so that we don't end up in the worst case, which is, here's the government estimate, let's take 30% off of that just so we can come in on a good negotiating, and suspecting industry adds 30% so that you end up somewhere in the right spot. All a bunch of guesswork that really doesn't do any good except for getting people to yell across the table from each other, or worse, put it in the hands of a contracting officer who doesn't have the technical support to be able to make a good judgment whether that's the right price that the government should be paying for something.
And I'd add, it's not industry isn't special in that regard. I buy a lot of stuff from the government, and and we do exactly the same thing to each other. So anyway.
All right, the next government question.
You guys want to take one?
Okay. All right. Let's see. Where can the Navy, I'll just ask the question, I'll give a little background. Where can the Navy best incorporate commercial design and oversight processes into military shipbuilding? Where should we avoid commercial practices? In the background there is ARCI, Acoustic Rapid COTS Insertion and Submarine Program, has been a successful implementation of commercial IT processes. NVR, good idea, hasn't worked out that way. So we've taken that in a different direction. So I would call those kind of first generation type of incorporation of commercial design and oversight processes. So what's the second generation, or maybe expanding the first generation into HM&E systems or mechanical systems?
I'll take a shot at that. But two items I think that from our perspective, or at least our company's perspective, and I'm not sure what you mean by second generation, because I don't know all the things you tried in first generation, but one of them is definitely moving away from construction standards more to performance standards, which is what the commercial industry uses. So when you put both of them together, then you just can't get there cost effectively. So you get the performance, but then you impose the construction, and that makes a significant cost increase. And then I would say the other one is to take a broader look the way the systems on commercial ships are designed, to look at the total installed cost, and we've talked about that before. It tends to be stovepiped into design, then material selection and procurement, and then construction, and then commissioning, and then acceptance or trials. And those are all independent, almost, selections. And the commercial world, in a way, default by outsourcing the whole thing as a package, it starts to look at the total cost as opposed to silos.
Did you give any examples or specifics, or someone else?
Well, I think that we see in many cases the equipment can be designed to reduce the construction or installation cost, so that the way in which you design, we do air conditioning systems, so the way you design ducting, there's a huge difference in the installation cost. So it might be a little more expensive up front, but really reducing the installation cost. And I don't think people are incentivized in the process. They have a budget here, they have a budget here, and they have a budget there. And they're only incentivized on their scope of that.
So who does that different design? Is that the shipbuilder? Is that the supplier? Is that?
It could be either one. It's just almost inherent in the process when you look at outsourcing an entire system. Then you get the total cost. We found that even the way in which we roll up costs in shipbuilding with the work breakdown structure doesn't even allow a shipbuilder to go back and find out what a system costs.
Because it crosses all the SWIBIS.
It's all SWIBIS in pockets, and it takes quite an effort to figure out what it costs in total.
What do you think about the idea of where, when you go to buy a ship or a large thing, the several systems of having a single system integrator for that particular system, propulsion system, a power system? Are you able to, is that a better methodology from industry's perspective to lay out those costs and find economies across multiple areas of either both construction or integration or choice of components and systems that go within or subsystems that go in the system?
I think the answer is yes, because it is looking at that total cost. And I think it's very important if you look at the correlation to commercial shipbuilding. That's the way they get down the total cost.
Well, so as you refer to total cost, you're talking about the cost to deliver the ship or the cost to own the ship for the rest of its life?
First to deliver the ship, life cycle cost you almost have to deal with as a separate subject, I think.
Interesting, because I think we do deal with them as very separate subjects, often contradicting one another, right? And I think that that's true in shipbuilders, it's true in the government without a question, and it's true as well in the suppliers of some of the important systems. But it's interesting in the different ways we have classically done ship design. In Navy product lines, submarines are not done the same as carriers, are not done the same as surface ships. And even among surface ships, that's an oversimplification too, right? Because some are fairly tightly coupled design and build, and others much less so. So it is, to me, having been raised on the submarine side of it, it's a bit unnatural to imagine outsourcing the ventilation system, because it's just so integral to everything else. And yet components of that system certainly are supplied by people other than the shipbuilder. But then the integration of all that into the design is in the hands of the final integrator. The debate we often have is, how is it that that cost-effective delivery of the ship didn't create some downstream life cycle problem that I don't want to deal with because it's going to cost me all kinds of extra, and whoever got the award for the low-cost delivery is long gone 20 years later and 30 years later when I'm still paying the big bill. So I'm interested in your thoughts about how a one-size-fits-all certainly doesn't apply, and how you cross the boundary to make it so that we can get, I think there is a place where delivery cost and life cycle cost minimizing come hand in hand. But I think we don't get there very deliberately very often. Any thoughts on that? Yes, sir.
Admiral Lewis mentioned something about off-the-shelf componentry in industry. We're able to do that. For instance, I'll give you an instance. There are UPSs in hospitals supplied. They work. They have to work. Right? Take that same UPS in their various sizes and put it on a ship. It's a commercial unit. Now we want to upgrade the components. Shipbuilder will not allow you to do that. It's modularized. You can pull this little card out, stick another card in, would know the difference, unless you checked it. And they want you to report any change you made, et cetera. So what have you got to say about that? Then hospitals, it must work. If you're in a surgery, it better work.
How often do they drill on that?
Excuse me?
How often is that exercised?
It's there.
Yeah.
Yeah.
Ours are here too.
It provides the power.
Right.
And should power go out, it's a no-break.
Yeah. One of the things we found is that sometimes the ups are down, right? And
The ups aren't.
Yeah, and the ups aren't, right? So, and why would that be? And it can be because we haven't built the rigor into the process to make sure that we're exercising these things to be able to build confidence that they're there when we need them. And it's not often because of component failure. It's usually because if we didn't build it into the routine, then we're not exercising it. And so small but systematic problems can arise that then pervade the whole ship. And so occasionally we'll have a problem because of that lack of rigor. A concern is that if we get the configuration wrong because we're not controlling that very well during the life of the ship, that we've lost control of knowing what the cause of any component failure is. But to your point, it is as important to the life of the sailors on that ship that the uninterruptible power supplies work as it is to the patients in the hospital. It can be life or death.
I think we should move on to the next question, please.
Actually, I want
Okay.
to
All right.
volunteer. I think we're dancing around a gorilla in a room, and the gorilla is who's accountable. When you build a ventilation system for a commercial customer and your contract says some number of CFM at some temperature at some place, and it works, great. Who's accountable when it doesn't work? When you're 100 CFM at 65 degrees and it's all built and done and it's 80 CFM at 80 degrees. Who's accountable? And because in the Navy, I'm accountable. The program manager is accountable, and I think that's kind of what we're struggling. We think we're accountable. If I give it to you, how do I enforce that accountability? If you think you're accountable, how do I enforce your accountability?
Good
How do I know
question.
you're accountable?
Simple answer, I think, and I don't know how easy it is for you to implement, but you don't buy it from me next time. It's a huge incentive.
Next industry question, please. Yeah, please, hold the microphones closer, because I think okay.
The Navy often states to us that it's focused now, there was a lot of effort on getting down construction cost, and now there's a focus on material cost in ship construction. Considering mil-spec components, there are few suppliers, and it seems like a significant price reduction through competition is unlikely to yield any significant reduction in cost. Alternative solutions could provide substantially more price reduction. However, there doesn't seem to be a timely way to insert these alternatives. It's even difficult to figure out the path to present these alternatives or the process to get acceptance and to get them early enough that you're not at the point where, well, it would be nice, but we can't stop and incorporate this now. So is there an interest in these alternatives, and could the process be made more transparent and quicker or at the right stage of the process?
So the basic answer is yes, of course. There is interest in that. How do we do it? I think that there is an argument here for being in with shipbuilders on all of those concepts really early, because as you say, when the concept arises after the details of design have already determined material ordering and parts are beginning to be ordered, then even for a lead ship, it's too late. So I think underlying your question is, how do I, in a specs and standards kind of environment where there are established requirements, how do I break through with ideas that might serve the Navy's needs very, very well, but aren't strictly compliant with that requirement, right? And so I think that the shipbuilder is the best advocate for that, but it doesn't mean that the Navy's not listening either. I'll give you an example of a place where we tried to open some doors on that. In the National Shipbuilding Research Program, there has been an initiative for a few years now to attack some specs and standards on a prioritized basis, going after what are the lowest hanging fruit where we know or industry can tell us where we have had a requirement, it might have been there for 30 or 40 or more years, and it is out of date or it doesn't buy us what we think it does, and that an alternative is present which offers something that's more economical or higher performing. And in doing that, what I've been looking for is the counter incentive needs to be beaten down. The counter incentive is every time we replace a mil spec or standard with a new version that's been updated, even in collaboration with industry, when we turn around and put it on a new contract, the price goes up, okay, because the price of change is an increase. Well, that's absurd if the whole idea of the change was to be a cost reducer. But it's like gravity. It kind of works that way, and it has to be countered by energy. Something's got to be done to lift it. So in order to beat that back, what I've asked for and gotten from the leadership of the NSRP is for the engineering heads and other corporate officers in all the shipbuilders together to be able to write something down with their signatures like John Hancock and so forth on the bottom of a piece of paper, somewhat non-binding, but it communicates within their companies and the government that everyone on the team, both sides of the negotiation for the next ship, have pre-agreed that this particular change was done in the direction of reducing cost. And in and of itself, it shouldn't be raising the costs of the next ship. So we've never used that as some kind of a legal binding thing, but what we have done is say, wait a minute, you can't tell me it'll be $1 million to study it, and then it'll raise the unit price of every ship by another 10. Instead, you have to acknowledge that we all worked on this, and it might have been last year, and the word didn't get to our negotiators, but we're going to use this piece of paper on the table to say, nope, nope, nope. This is what gets your question addressed. So what we could use is more active engagement that way at the supplier level, and I think through the shipbuilders is a good way to do it. Just because I know that's where the incentive exists for shipbuilders is to find solutions to a big integrated complex engineering challenge from suppliers who are smart enough about the components to say, this is what you need to tell the government, okay? Because the system exists for us to have that discussion, in my opinion.
Well, I think it also goes to the question that Emma Lewis mentioned in terms of accountability. You know, when there's an offer that there's something, whether it comes from the government or industry, that we can reduce the cost of something, either through some new change or even from the beginning, the solicitation, where we make very flexible the ability to put in a commercial product, vice a mil spec or a military standard. The question becomes prove it. Show me how those costs are really lower, and it's not just a brochure kind of thing of, yeah, I can name that tune in 2 notes instead of 3. And then the next piece is the accountability. Is you say this, and what are you willing to commit in terms of accountability that, in fact, it will do exactly as you described. There is going to always be the cost of change. There's no way that you can probably get completely away from that. But you can make the case, and it'll go to the question I'll ask in a little bit about, can you make the initial cost, can you offset that with truly a provable life cycle long-term reduction in cost? Then you can get people to sit at the table. I think one of the other challenges we have within the government is that our standards of proof are pretty high, and it requires a tremendous amount of analytics for industry to prove that these items, in fact, will do all of these things. And so even if you get a commercial item proposed, then if the standard is, well, you've got to go through all these analytics and studies and books of information that prove that, well, you just threw all that cost into what was originally a lower cost item, and now it costs the same or more than what was originally proposed in terms of a mil spec or a mil standard kind of a thing. So streamlined processes there, I think, can be something in terms of approval and acceptance that, in fact, it will, in fact, produce those lower costs. And that's something that, obviously, we all need to work on, and there's a little trust component that goes there with that as well.
The other thing we're doing, I mentioned it yesterday, a crosswalk between commercial equipment and mil-spec equipment. And I briefed the details of that, of our first 2 crosswalks at the Service Navy Association last month. For electrical generation equipment, mil-spec equipment costs 3 times as much as commercial equipment. And we never could answer why. So we did about a 6-month study, and now we know why at a fairly high level of granularity. So now what we're doing, that study completed in December, now what we're doing is we have a list of things that drive up the cost from a mil-spec perspective, and how much each one drives up the cost and why. And then now what we're doing is going through that list saying, does that thing matter to me? Does having 43 checkpoints during the assembly process, which costs us 10 cents a kilowatt hour, matter enough that I'm willing to pay 10 cents extra a kilowatt hour to have those checkpoints? One that came out frequently in the study was the average military procurement has 49 seed rules. The average commercial procurement has 4. So the question we're asking is, does anybody read those 49 seed rules? Do we use those 49 seed rules? Because we're paying for them. And we pay you to generate them, and you pay people to sit down and write them. And they should be useful to us. And if they are, then we should buy them. And if they're not, we shouldn't buy them. So we're embarking on that journey in electrical generators, and we're embarking on that journey in large propulsion motors, so that we as a customer understand what we're asking for, we understand what we're buying. And my expectation is we're going to find out that we didn't know we knew what we were asking for, but we didn't know what it cost to get it. And then, so we're going to loop back around and have a discussion with ourselves about, is this worth 10 cents a kilowatt hour or kilowatt to get this thing that I'm paying for? So we'll see how that goes.
And also with that, has something changed since the requirement was established? Is there repeatability in manufacturing such that the quality is high now because of something different? If yes, and we understand that there's either a difference in our fault tolerance or a difference in the inherent quality that comes through a commercial line, then maybe we don't need all the same checkpoints, for example. On the other hand, some exotic not so exotic, but high energy density, power density batteries are highlighting for us that maybe nobody understands just how important the control of fabrication processes is and are, because the consequences of that are just being discovered by people who are in businesses of high risk, like the Dreamliner. With those kinds of challenges in the lithium-ion battery business, you got to get manufacturing right, and actually that may be a place where industry is calling for more manufacturing checkpoints. So I think that there is again, not a one-size-fits-all, but there is a good point in what Dave's saying about challenging the status quo, and then using something objective to decide, do we have a requirement for a reason, or do we have a requirement for tradition?
Just as a last piece of that, I think also, and I guess I'll wait till I ask my question, but the question is what we're requiring, does it require such a very specific piece of equipment to go in there, or could you in fact offer, and do we have the ability to offer something that is good enough? If the spec says that the pump had to be 91 gallons per minute, would 90 gallons per minute and it be a standard commercial size be okay? And we've got to have that dialogue, because if there's a significant cost reduction, we have to have processes by which that is okay, and we can end up reducing the cost.
The next government question, please.
This is really a good, previous discussion was a good segue. One of the things is that, again, when we do these solicitations to buy equipment or a ship, we are we want to do a couple things, obviously, is to get exactly what we want in the sense of it being able to meet our requirements as set forth by the sponsor, by the operational elements, so that the asset or piece of equipment does exactly what we expect it to do. And so we layer in, over a long period of time, a bunch of structure into that solicitation so that we are guaranteed to a 99.99%, at least we try, and to get exactly what we want so that the risk is near zero of getting something we don't want and expending the taxpayers' precious dollars on something and then be disappointed. I think what we've done is we've created this very complex solicitation process that does that, but I'm not so sure that it necessarily allows industry to put something forth that may still meet the basic requirements. So my question is there ways that we can better structure our equipment and our ship repair solicitations to encourage more cost-effective proposals from industry, and not so much the specifics, but more broadly, the way we ask for things? Is there ideas from industry, and I know this is an ongoing dialogue, but is there some broad areas that we can take a look at?
Well, one of the issues that you create in the way that you structure your RFPs is that you require 100% compliance almost regularly. If I want to offer you something, your example before, a 90-gallon pump instead of a 91 gallons per minute pump, I can't do that because I'm not fully compliant. And what's the result? You throw out my proposal without consideration because I can't ensure compliance, even though I might say to you, I can provide you that for half the price if you can live with one less gallon. There's no means or methodology most of the time for us to come to you and say, I have what this should cost for you to serve your results, because there's no avenue for us to do that. And so the challenge is for us on the industry side is, how do we get in front of you to say, there's a better way to do this, or there's a less expensive way to do this, but you ask the question, you put out the RFP, and if we're not 100% compliant for any reason, you don't consider what we say. Further to the comment about the number of FAR clauses or seed rules, you drive people away from the business who say, I'm not dealing with all that stuff. I've got stuff that could solve the problem. I have equipment that is fully capable of providing the government what they need. But 47 seed rules, 59 FAR clauses, most of which have nothing to do with the standard piece or component that I'm utilizing. You asked the question about ship repair, advanced planning for some of us. I'll use my own company in this example. We were working on the Lewis and Clark class, TAKEs. We're doing some modifications to the freeze-chill areas for some improvements in that regard. Well, the government didn't decide which shipyard that work was going to go to until 25 days before the availability started. So what did we do? We made reservations in 3 different towns because we had a group of people that had to go. We knew that we needed to be there, and so we made reservations in 3 different places and had logistical plans set up not for one place, but 3 different places, because the notification was not sufficiently early for us to logistically plan in the most efficient manner. So relative to the questions, at least from our perspective, those are ways that if we can spend sufficient time to do advanced planning, it's always less expensive if you have sufficient time. We got it done, we executed, but not the most effective cost.
I think the points you made are really interesting ones, and the one I would like to focus on is this idea that there's a gap or a gulf between the government saying I need a responsive proposal and a proposal that appears to be unresponsive because it falls short. It seems to me that to close that gap, there's got to be a way to have the conversation that you were alluding to, that in the 90 versus 91 GPM example, that your 90 is responsive, and here's why, right? Because you would make the case, I think, that even if the number was set at a value that was just beyond the range you've got, there are other ways to solve the problem, other parts of the solution that can be exploited so that we can get 90 GPM out of that prime mover or that pump, but we can get a system that'll work just fine. The airplane's going to get filled with fuel at a rate that is still going to be satisfactory, and maybe that's the thing we care about a lot more than we care about what the value of the flow meter is. In fact, it might be within flow meter error, right? So that conversation could be a is to, is not after the fact when we're arguing about whether or not the award was made fairly. But it would be a lot healthier if it was a part of the proposal as well as part of the pre-proposing discussion. It would be brilliant if we were smart enough to get it right the first time, but suppose we're not. I'd be great with having government receive a proposal that says something like, here's what I've got, and in these areas that I've highlighted, this is why I believe I'm responsive. And I don't know, you're a PEO, and you were a PEO, and so I'm interested in my colleagues' position on whether or not in the evaluation of those proposals we'd entertain that argument, because I think on principle we should.
Well, in the structure, of receiving a solicitation and all of the process that goes with that, and the like you said, the pass-fail, kind of the binary choices that are made. The key is to obviously, for those that do the evaluation of the proposal, to have that latitude, and that has to be written in up front clearly, because once you get to the receiving the solicitation, you're locked into whatever processes you agreed to for fairness. I mean, you can't change the rules in the middle of a solicitation. That's not fair to everybody. But the question is, how do we craft those things? And one of the things that we did on our most recent ship solicitation was to consult with industry a great deal and listen to things that we test drove some draft specs and things like that, and got a lot of great feedback saying, if you ask for this, you're buying something way more expensive than I think you really want. And we took that and drove that into the final specification. So there is ways to have that dialogue, but once you get to a certain phase of the solicitation review and process, you're kind of locked in because, again, the FAR is the FAR, and you've got to be fair as well. So I think the dialogue has to occur there, but I think there still could be some ways in the solicitation, like we've also allowed some, if you're going to provide something, and counter proposal is to provide the analytics that go with it so that our evaluators can review it to see if in fact it does meet. But I think in the case of let's say the pump example extrapolated to a larger thing like a KPP for a particular thing, a half a knot of speed or whatever it might be, there isn't that kind of flexibility, and it becomes a go, no go. And that, again, as Admiral Eccles said, that may not be in the best interest of the government. So I think we have to continue to look for ways to put that into our solicitations so that we can have a method during those particular phases, which are very regimented, very controlled, to be able to have that kind of a discussion amongst ourselves that, yeah, in fact, it did meet the requirements that we really, really want with a particular item.
Well, let me ask a question. How, when we do try to do things like industry days or some sort of open discussion about those sorts of technical issues, the pushback we often get is, well, I don't want to share that with my competitor. So I'll talk to you privately, but I'm not going to talk to you publicly. Could you expand or expound on that at all, or any of you?
Well, that's certainly, Admiral, always a challenge because all of us are working hard and spending our own R&D money relative to trying to make sure that we're determining a better solution. And I know, having sat in your predecessor's office once, talking about an idea and saying, here's a way I think we could save 20% in a particular area. And everybody loved it right up until the time said, okay, well, what I need you to do is go ahead and publish all that information so that your competitors have that advantage and then everybody can bid so it's fair. Okay, well, obviously you might understand from my perspective, I didn't think it was fair if it was my idea and my R&D money for me to tell everybody else what a good idea I had. And so Then we get all the way back to should cost, okay? Well, this is what it should cost right up until you tell me that you want me to give it to everybody else. And so we have to try to find a way. So I think industry days are productive from our perspective because there is some dialogue that we can have, not unlike the dialogue that we're having today relative to ways we might find to general solutions, but we have to find a way, in my view, to allow innovation and contribution by those that have invested the money and spent the time and done the work to flow into the system and manage the process of the FAR and those things. And I know you have a very difficult challenge. I know the challenge is hard on your side, but the challenge for our side is a lack of incentive for investment in those kinds of things because you won't let us use it unless we give it to everybody else.
Yeah, can I jump in and then right back to you, sir? I think the point you're making there is spot on, and we can speak out of multiple sides of our face if we're not too careful about this. Competition, the advantage in competition is certainly not, that is the advantage to the buyer, is certainly not just in the pricing pressures, but it is in the diversity of ideas that comes from a competitive environment, and those ideas include some intellectual properties that ought to be respected. In fact, I think the law requires that we do that. So it's important to us to not only get the best price, but to get the best price because the ideas that come from the winner are the cleverest ideas. And it is incumbent upon us to work that so that we're getting that. Otherwise, we're diluting the entire advantage of competition other than simple pricing pressures, in my opinion. Yes, sir.
I don't have that problem. Because we're a small business, and we compete with the biggest, and we can always beat them on price and on technology, because we keep up with technology, and the only person that I have to convince is my wife that we ought to spend the money, and I'll listen to her for 2 minutes and go. So I don't mind. I think the problem is this, that we study systems and we study the problems of other systems, and then we know that there is technology to solve, but I think they're lacking. I don't mind telling my customer that, look, the problem then exists that the customer is now going to tell my competition, and they're going to pay them to fix their unit because it's cheaper for them to do that than have me supply the system for a number of reasons, mostly all those seed drills and all that other nonsense that costs a fortune. That's the only situation.
Well, let me ask, I've had some good experiences with lowest cost, technically acceptable approach to procurements. And the idea, in my mind anyway, is as long as we've correctly defined the technical attributes, and I recognize the earlier discussion, that preserves your intellectual property, if you will, and then we default to pick the lowest cost technically acceptable. If you've innovated in a cost-wise way, we don't necessarily disclose what you've done to your competitors, but we get what Tom Eccles was talking about. Is that, I know that's an issue, that's a topic I hear berated in the press. Just curious what your thoughts might be, as maybe that's a mechanism, or maybe it's not, I don't know.
I think that from a supplier perspective, we're okay with that. We're a little nervous about whether or not you can define all the things that are important to you so that this minimum amount, and then what if we offer something better than that? It's got more value to you, so could it be structured to also incentivize more value?
That might be complicated.
So let us move on to the next question.
That's a traditional solicitation where we evaluate technically and evaluate cost, and then the economic balances in a way that's defined in the RP. That gets to kind of your original question. So we can do technical only or cost, and so, go ahead.
Let's have the next industry question, please.
Thank you. For perhaps the first time, a potential Secretary of Defense has been grilled by Congress concerning his stance on environmental issues. The mandated use of biodiesel in U.S. warships at a huge premium to taxpayers comes at a time when the Navy has been directed to aggressively control costs through globally competitive industry bidding process. By paying 8 times more for biofuel, the justification appears to be to spur fuel development, future economies of scale, and to drive the advanced fuel industry as part of the economic policy of the current administration. Will emissions control become an issue, also become an issue, as is the case with commercial ships now operating in U.S. waters? And the basic question is how far will this Navy, Coast Guard, go toward being green?
Can I jump on that? Because I'm really interested in hearing what Admiral Ron Rábago has to say about it.
Thanks, colleague. Well, certainly, we've structured in, and we're working closely with our brothers and sisters in the Navy in terms of looking at how we can make our ships, certainly more green. We actually have a number of initiatives exploring things with biofuel. We also, the Coast Guard has another unique perspective in the sense that we participate in international bodies like IMO, which sets international standards, both for emissions, for the fuels, and a number of areas that certainly support kind of the broad context of greenness in there. Coast Guard's position is that we want to be as green as we possibly can. And so we are exploring all of those areas. Where we will fall short from perfection, as it were, is where it gets inhibits our ability to do our mission. And so just like the Navy, you can do a lot, but at certain points, if you can't perform the mission that we're required to do, then you have to start to see what kinds of compromises you have to make in there. But our position is start green and then adjust from there. And we are certainly, like I said, partnered. We did a experiment using some algae-based type bio kind of fuels on one of our 175-foot buoy tenders, and we ran that on the ship to actually go out and do missions. And came back with that and disassembled the engine to a degree to make sure that there wasn't any issues, because there's a kind of a cultural thing too, is you want me to put this fuel in, the manufacturer never said that this was going to be okay. I need to prove that it's okay as well, because we certainly don't want to take risks with our assets either. But I think we've got a measured way to do that so that we can explore those things. The cost piece is going to have to come through innovation in production and manufacturing and those kinds of things, which we think that as we explore those things, industry will find ways to bring the cost down, provided there's sufficient market, obviously, to do that. And those are forces that obviously that'll have to play out. But we, from our position, do look for every way that we can be compliant. We continue every new ship class. We continue to improve on the tier level for the emissions requirements for our engines, and we'll continue to do that up to the point where if we select something, it fails to do mission. Then we would not be responsible to the taxpayer or our nation if we did that. So we push as far as we can go. Some of it will be technology, some of it will be science in those areas, but we are certainly pushing out there. And we also want to do is our position on the IMO is to make sure that we look at pragmatic ways that simply support commerce and are responsive globally to the world's needs and desires to obviously be protective of our environment, because that is one of our statutory missions.
In relation to mission capability, do you think the pendulum would fall more toward fuel development or emissions control?
I think right now the more practical in front of us is probably emissions per se, but we're watching closely and looking at the development of the science associated with the fuels in terms of the chemistry and the production methodology and those kinds of things. But we're small, and so what we generally do is we partner very closely with the Navy, quite frankly.
Yeah, and I've got to say thanks to Ron for being so good-natured and taking that ping pong I just handed him. The Navy position is right in line with what Coast Guard is doing. Let me elaborate a little bit, though, on things that are perhaps well-known, but just for the sake of context. Secretary Mabus has been very plain that getting into alternative fuels and their application in military use is a part of the platform he came in with as a Secretary of the Navy. As a part of that, he would, I think, argue that not only is a future of a greener kind of pressure economically going to be a good thing for us, but he would say energy independence is an important aspect of decoupling ourselves from traditional fossil fuels. And this is a long view. And in fact, as he paints the picture in remarks he's given many times, he goes back to the unpopular nature of shifting from sail to machinery and shifting from wood to steel and shifting from coal to oil and so forth. And in all of those kinds of technology changes, there were periods of great inertia to be overcome in order to move in a direction that's new, different, perhaps challenging, and certainly an area of unknowns in technology. And I think he has done that for a range of reasons, and I don't want people to think that it's simply an ecological discussion or simply an economic discussion. I think it's also about the way military power and logistics for a forward deployed force needs to consider its source of energy and what the lines of communication are for that logistics trail to get us that energy. As we have taken on the first couple of tasks of demonstrating in 2012 and working to deploy in 2016 with some alternatives, one of the things that we've all stood for is the technical rigor in ensuring that the machinery is really up to the task. And it turns out you can burn quite a lot of different stuff in the machines that we build because the robustness that is in that machinery is sufficient to handle a range of fossil fuels. Within that same range of fossil fuels lie some of the same things we've been experimenting with in alternatives. And so whether those come from products like camelina or algae or other sources, we have learned that chemically we have the ability to put together a range of constituent considerations and then look at the properties of each of those and determine whether or not we're inside a range that's allowable. And then having done the chemistry and the the lubrication science and all of that, then we go and demo it. And we've done those demonstrations largely ashore before taking them to sea. And because we do have these similarities in equipments, we can leverage from one service to another. Coast Guard and Navy can each use the results of these tests. And by the time you saw people in RIMPAC 2012 operating in gas turbines and diesels and shooting airplanes off the deck of the carrier, all of those things have been done ashore before they were being done as a demonstration at sea. In fact, they'd generally been done at sea before they were done at sea. Okay? We like to take it to sea before we take it to sea.
Well, the next industry question is to you, Admiral Whitney. Thank you, Joe. But inasmuch as I couldn't be here and in the interest of time, I will defer my place in the queue to my industry colleagues. Thank you, Mark. That was very generous of you. Over to you, Tony.
My question to the admirals. Do you believe it serves a good purpose for a supplier after contract award to meet with Navy reps for their meaningful input?
Yes. We discussed this in the Global Shipbuilding Summit yesterday. There are value engineering clauses in I think most if not all of our contracts, And the intent of those clauses are to cause that exact discussion to occur. What we've been talking about up this morning is prior to contract award. Your question is excellent. Okay, now we're in a contract. We're buying what we're buying, and now you have a better idea. I think I certainly am very interested in implementing that better idea in a shipbuilding program from a vendor perspective. Some of the obstacles that Admiral Eccles talked about do come up at that point, because now we're inside a contract, and things like overhead rates and NRE and other things which may be not as relevant prior to contract awards start coming in. And certainly I have lots and lots of bad experience with a vendor coming in with an idea that dramatically reduces their cost, and after we put it through the contract machine, it comes out the other end is all you have to do, Navy, is pay an extra $100,000 and you'll get this great deal. And I'm going, wait a minute, I talked to the guy at the beginning of this chain and it was good, and how come it's not good now? And frankly, Tom has a lot of recent experience with that, and I think we're cutting some new ground in taking those good ideas, whether it's a vendor idea or a shipbuilder industrial process idea, and having it turn out to be a good thing for the customer price-wise when it's done, when the conversation is over and finished. Do you want to elaborate on that at all? These are your paint initiatives and the pipe and welding.
Yeah, right. I'm trying to think of how to put better context on it than that, but I do agree there's a place for that dialogue. I think we can do it without breaking the integrity of contracts. I think it's really important that we find some balance between respecting those ideas and the properties that belong to companies individually, and yet not stovepipe the thinking to the point where only those awardees of those contracts get to make use of the ideas. And so, I mean, how do you do something like figure out that high solids paints produce a much more robust surface for us at lower cost, and not propagate that idea around the industry? And so for most of us, we'd all say, it's paint, you know, how hard is that? Well, there are a couple of companies out there who think that's the whole thing. And as somebody who spends a lot of money on corrosion control, we all would say, yeah, paint's one of the big things. So I think there's a bit of a conundrum. It doesn't mean it's not a solvable problem, but I think there's a way for companies with innovative ideas to be profitable and win those kinds of awards, and at the same time take fundamental good ideas and get them on the street in wide applicability, so that while the details of how people have competed can be preserved, the basis of promulgating the ideas broadly is still available to us.
I'm thinking back to what you mentioned earlier about changing the card in the UPS module. We've had a lot of good luck with keeping the shipbuilder on one side of the interface, the bolt pattern, the cable, the pinouts, and then the vendor, if it's a vendor supplied equipment, inside of that. So if the box comes and the bolt pattern's the same, the pinouts are the same, the cabling's the same, but the bits inside are different, to me that's kind of an issue between the vendor and the government, and should not be a shipbuilder discussion. I learned this by accident, QQ89 on a DDG. The OEM wasn't finished inventing the sonar, and I had to build a ship. And we quickly figured out that what the shipbuilder cared about was the big cabinets, not what was inside them. So the OEM delivered the big cabinets to the shipbuilder in time. They were empty. And then 2 weeks before trials, the OEM showed up with a bunch of suitcases full of cards. We populated the cabinets and had a great system. It worked great. And so I've kind of carried that forward as long as you as an equipment supplier stay inside your box, pun intended, I think there's a lot of things that could happen. The shipbuilder doesn't need to necessarily know if that's an A1 card or an A2 card or a V1 or V2 of that card.
Okay.
So-
Let me give you an example why I asked the question. We were on a particular program and met the spec. And on sell-off, the Navy showed up and they said, you must have this and you must have that. So at that point, it becomes very expensive to try to do something with your equipment. You could do it. You may have to change boards, you may have to do whatever you have to do to meet what the Navy said should have been met, which was not in the spec. I also have had other experience many years ago when the doors were quite open. We spoke to the Navy people who actually serviced the equipment. We said, look, we're building this equipment. Tell me what you would like to see. What would help you? And we build that in without a cost. The other reason why I asked the question is because we look at a spec, we know more about that equipment than my customer and their engineers, unfortunately. And there are things that we could do to reduce costs, but we're told to build it to the spec.
Okay, that's last one is the value engineering part of it. The first bit about you had to meet specs that weren't in a contract, that disturbs me. That shouldn't be that way. I've certainly gone the other way where a piece of equipment didn't meet the spec, and then we had a discussion with the vendor. And we can waive that if it's appropriate. But we as a government shouldn't be telling you to meet specs that are not required in the contract. I think that breaks the covenant, certainly.
The law.
Or that too.
Yeah.
So I'm a little concerned about that one.
But actually, in that example, you might both be talking about the same case, right? Because that's usually how that conversation goes, is to, is not, right? And
That's why we have lawyers.
Well, you will, incidentally.
so that's why.
You will meet the spec.
Yeah.
You will meet the spec.
Okay.
Yeah.
You'll just go about designing your equipment a little differently.
Well, I think there's also, it goes to your cabinet example, but that could be even if you have something in the cabinet that by the time you get to the end of the building process, there's an obsolescence component that goes to it. Mm-hmm. And I think part of the proposals and the way we should be asking for things allows for that level of modularity and commonality at the interface level so that, in fact, you can pull that thing out and stick in the latest, greatest thing in there. And, of course, you get into the software stuff, too, which is always fun in terms of cost and that. But I think the other part of this is that some of the value engineering sometimes is your upfront cost and then your promised life cycle cost savings. And I think we have been sometimes disappointed in the sense of promises of life cycle reduction. And then if the accountants look at it and they go, well, it'll save you $20 million later with a $2 million up front, you go, well, first you have to have the $2 million up front. That's usually the toughest thing. But even the $20 million is a kind of a promissory note, depending on a lot of things. And I think if there were ways that we could certify, have some sort of accountability, some sort of a methodology by which we could actually say with some confidence that in fact that $2 million is justified for that $20 million in savings in life cycle, or even in the near term, in the next 5 years or something, you'll see those reductions in cost. We could figure out ways that we all felt comfortable with that and there was some accountability in that promise, then I think people would be more inclined to take those good ideas and implement them and make the upfront investment because the promissory note actually has some heft to it.
I think you've hit on an important point. I mean, we've been kind of noodling at this for a while with a thing called turnkey, which literally legally separates the cab. Excuse me. We've been noodling on this with a thing called turnkey, which contractually separates the inside of the box from the outside of the box. And then this flexible infrastructure we talked about a little bit yesterday makes it easy to change boxes and moves that interface point actually to the bulkhead away from the box itself. And again, those are a couple of, and then modularity takes it the next step and puts the box inside a box and further separates it from the ship. And all of those are geared to do exactly what you talk about, is allow something which changes very quickly, which could be your equipment, to connect up with something which changes very slowly and expensively, which is the ship design. And I think a key we're struggling, or a process we're struggling with, is how do you have this fast-turning thing and this slow-turning thing operate together without clashing the gears? And I think what you're talking about is the sound of the gears clashing. And I certainly solicit after this your thoughts on that, and because I think we have room to improve there.
Anything else? Well, I don't think we have time for another question, but I would like to ask the audience what they thought of the format of this point-counterpoint. If you would raise your hands, if you liked this format, give me a show of hands, because we'll try it again if you liked it. I know the panel liked it. Personally, as the moderator, I absolutely hated it, because as moderator, I got to keep my mouth shut, and I just wanted to jump in at 10 times in every question. And so I would like to thank both of these great panels and all the panelists. Thank you very much. And with that, we're adjourned.